Astronomers initially concluded that the interstellar object, designated 3I Atlas, had passed safely through the solar system on a one-time trajectory and would not return. However, new analyses from researchers at Harvard University have suggested that its path may be less straightforward than first believed, and its course is being re-examined. NASA continues to monitor the object closely, though its current assessments state that it does not pose a threat to Earth. Central to the discussion is Professor Avi Loeb, an astrophysicist at Harvard University, known for his work on interstellar objects and for raising the possibility that some may represent artificial rather than natural origins. Loeb is a well-established figure in the field. He has published extensively in peer-reviewed journals, served as chair of Harvard's astronomy department, and acted as an advisor to NASA. His perspective that interstellar visitors might in rare cases be technological in nature has sparked both public interest and significant debate within the scientific community. 3I Atlas has magnified this debate. The object is immense, roughly the size of Manhattan Island, far larger than any interstellar visitor previously detected. Oumuamua in 2017 and Borisov in 2019 were each only a few hundred meters across. At about 20 kilometers in diameter, Atlas dwarfs them. Astronomers had calculated that finding an object this large should be an event spaced out across tens of thousands of years. Yet here it is, barely a decade after systematic sky surveys began. That statistical improbability alone raises questions. The mysteries deepen when examining Atlas's trajectory. Instead of wandering through at a random inclination, the object entered our solar system on a path aligned within just 5 degrees of the ecliptic plane, the flat, disk-like region where the planets orbit. Such alignment has only a 1 in 500 chance of occurring randomly. Stranger still, its course will take it past multiple major planets, Mars, Venus, and Jupiter, before swinging toward the Sun. The probability of this sequence happening purely by chance is estimated at 1 in 20,000. To some, it resembles a carefully arranged tour of the solar system's greatest hits, not a random interstellar flyby. Even more curious is the direction of its motion. Atlas travels on a retrograde orbit, opposite to the planet's flew around the Sun. This is unusual but not impossible for interstellar bodies. However, in the imagination of some theorists, such a trajectory would be ideal for systematic study. Moving against the grain gives longer encounters and better observational geometry for anyone or anything interested in surveying planets. Then there is its speed. Atlas races through space at roughly 41 kilometers per second, nearly twice the velocity of the fastest spacecraft humanity has ever launched. This falls within the range of natural interstellar velocities, but some point out the coincidence. It is fast enough to cross the solar system, but slow enough to be tracked and studied by human technology. Loeb himself suggests that the speed appears almost calibrated for detection by civilizations like ours. Whether that is coincidence or intent remains unresolved.
The Hubble Space Telescope has added another layer of mystery. When astronomers pointed Hubble at Atlas, they expected to see a familiar cometary pattern, jets of gas and dust streaming away from the Sun, forming a tail that always points outward, sculpted by radiation pressure and the solar wind. Instead, they saw something altogether stranger. Atlas glowed, but not behind it. The glow appeared in front, pointing toward the Sun, as if defying the basic physics of sublimation. The absence of a proper tail, especially as the object warms, is deeply puzzling. If it is made of ice and rock, its surface should be venting material in predictable ways. The fact that it is not suggests either a composition wholly unlike any comet or a mechanism outside natural explanation. NASA officially classifies Atlas as a comet and assures the public that it poses no danger to Earth, predicting it will remain at least 150 million miles away. But skeptics point to past errors. In 2018, astronomers mistook Elon Musk's Tesla Roadster, launched into orbit by SpaceX, for a new asteroid until its artificial origin was clarified. If a car could briefly fool the world's experts, could an unprecedented interstellar visitor be more easily misjudged? Within the academic community, Loeb's insistence on entertaining the possibility of an artificial origin has provoked sharp backlash. Many scientists regard even mentioning alien technology in connection with astronomical objects as reckless, fearing it undermines the credibility of astrophysics as a discipline. The prevailing view is that extraordinary claims require extraordinary evidence, and until such evidence exists, speculation should remain firmly in the realm of science fiction. For his critics, Loeb's willingness to speak openly about the prospect of alien technology risks distracting from more conventional but testable explanations, and it invites public misconceptions about the scientific process. Loeb, however, counters that raising these possibilities is not about abandoning rigor, but about ensuring that science remains open to all hypotheses, no matter how unconventional, until the data rules them out. To provide a framework for evaluating such claims, he has introduced what he calls the Loeb scale, a ranking system intended to measure the likelihood of an object being artificial. On this scale, 0 represents a purely natural explanation, while 10 represents certainty of technological origin. In the case of 3I Atlas, Loeb places the object at a 4, an ambiguous middle ground. To him, the object exhibits anomalies inconsistent with typical comets or asteroids, yet there is not enough evidence to justify calling it artificial outright. This carefully hedged position unsettles his colleagues even more than a definitive claim might, because it resists dismissal. It forces the community to sit uncomfortably with uncertainty, acknowledging gaps in knowledge rather than closing the case prematurely. The dispute over Atlas highlights a broader issue: the culture of modern academia. Loeb argues that universities have become increasingly risk-averse, structured to reward consensus and incremental progress rather than bold, paradigm-shifting exploration. Research funding often flows toward projects that reinforce prevailing theories rather than challenge them. Young scientists eager to build stable careers are taught to avoid controversy. Loeb frequently contrasts this environment with the early 20th century, when pioneers such as Niels Bohr, Werner Heisenberg, and Albert Einstein upended physics with daring theories of relativity and quantum mechanics. In that era, radical ideas were not only tolerated but encouraged, and the culture of science thrived on intellectual risk. Today, he argues a graduate student proposing a similarly disruptive hypothesis would face skepticism not only from colleagues, but also from grant committees and hiring panels.
From Loeb's perspective, the hostile reaction to his interpretations of interstellar objects is not simply about data, it is about institutional inertia. He views the controversy around 3I Atlas as symptomatic of a system more concerned with protecting orthodoxy than with pursuing truth. Whether Atlas is natural or artificial, he argues, the scientific community should be willing to ask the difficult questions. If, however, Atlas were one day confirmed to be of artificial origin, the consequences would extend far beyond the scientific debate. The economic implications alone could be staggering. Global markets might plunge in response to uncertainty, with trillions of dollars in value evaporating overnight. Defense contractors would likely see their valuations soar as governments redirected resources into security and intelligence efforts to assess potential threats. Meanwhile, entire industries could collapse if confronted with alien propulsion or energy technologies that render human systems obsolete. Fossil fuels, nuclear reactors, even solar and wind power could become irrelevant within years. Infrastructure that nations have invested in for generations might be reduced to historical curiosities. Financial institutions would find their risk models useless. Insurance companies would have no framework for calculating coverage in a world where extraterrestrial technology could disrupt entire industries at once. International trade agreements might unravel as nations scrambled to secure access to new knowledge, while geopolitical alliances could fracture under the strain of recalibrating humanity's place in the cosmos. Education systems, too, would require complete reinvention, preparing students not for existing industries, but for a world defined by technologies and possibilities far outside current imagination. The shockwaves of such a revelation would ripple through every aspect of civilization. For the moment, however, speculation about economics or geopolitics remains secondary. The immediate priority is gathering data before observation opportunities vanish. Atlas is expected to reach its closest approach to the Sun on October 29, 2025.
Unfortunately, Earth will be positioned on the far side of the Sun at that time, a cosmic alignment that makes ground-based observation nearly impossible during the most critical period. For some, this is nothing more than bad luck, a quirk of orbital mechanics. For others, the timing feels almost too precise, feeding suspicions that concealment might be built into the object's trajectory. In the absence of optimal ground-based visibility, space-based observatories provide the best tools for study. The Hubble Space Telescope, though aging, continues to deliver high-resolution imaging, while the James Webb Space Telescope offers infrared sensitivity capable of probing thermal properties. Together, these instruments will attempt to track Atlas during its solar encounter, searching for behavior that can distinguish between natural and artificial explanations. The most decisive test will come from monitoring for non-gravitational acceleration, subtle changes in trajectory or velocity that cannot be explained by the gravitational pull of the Sun or planets. In comets, such deviations can sometimes result from jets of sublimating gas, but in Atlas's case, the absence of normal cometary behavior makes this explanation less convincing. If researchers detect shifts and motion inconsistent with known natural processes, it would provide the strongest evidence yet of artificial propulsion. So far, no such changes have been observed. But as the object brightens and draws closer, the precision of measurements will improve significantly, offering the possibility of a definitive answer. The next several months will therefore be critical. The question is not only what 3I Atlas is, but whether the scientific community and society at large are prepared for the answers. The coming months are critical. Loeb predicts that by September 2025, the heating process should force Atlas to reveal its nature. If it is an ordinary comet, jets of gas and dust will erupt spectacularly, forming a brilliant tail. If it is not, then its silence, its refusal to act like a comet, may be more revealing still. His team, working under the Galileo project, has instructed machine learning systems to scan for anomalies, whether unexpected outgassing, fragments, or even the release of smaller probes. They will also be monitoring Earth's atmosphere for unusual activity following the closest approach.
The implications are staggering, almost beyond comprehension. With the discovery of 3I Atlas, humanity once again finds itself confronting questions that cut to the core of our place in the universe. Could this be the first unmistakable sign of another intelligence reaching across interstellar space to announce its presence in our solar system? Or will it ultimately prove to be a natural body, strange and unruly, yet still born of familiar cosmic processes, reminding us of how little we truly know about the universe we inhabit? Either outcome would carry transformative consequences. If artificial, it would represent the greatest discovery in human history, confirmation that we are not alone. Such a revelation would instantly reshape our sciences, our religions, and our philosophies, forcing us to reckon with the knowledge that intelligence has arisen elsewhere and perhaps long before us. If natural, the significance is no less profound, for it would require us to rethink cometary physics, planetary formation theories, and the very statistics of interstellar traffic, forcing us to acknowledge that nature's creativity still vastly outpaces our understanding. What we know of 3I Atlas is already extraordinary. Its trajectory is hyperbolic, confirming that it is not bound to the Sun but passing through on a one-time interstellar journey. Estimates based on Hubble and Rubin observatory data suggest a nucleus as large as 7 miles across, making it far larger than either of its predecessors and the most massive interstellar object ever observed. Already, telescopes are reporting evidence of comet-like activity, a developing coma, outgassing, and dust emission, consistent with a body heating as it nears the Sun. Yet, even here, anomalies appear. Some evidence suggests that 3I Atlas may have shown activity as far out as 6.4 astronomical units, an unusually distant onset for cometary behavior, raising questions about its composition and the volatiles it contains. Tracing its path backward through space using Gaia stellar data has revealed numerous stellar encounters but no clear home system, leaving its origins cloaked in mystery. For Avi Loeb and others willing to challenge conventional assumptions, the most pressing question is not what 3I Atlas is, but how humanity responds to it.
Loeb has long argued that dismissing the possibility of extraterrestrial technology without serious consideration betrays a culture of scientific dogmatism, one that is ill-prepared for paradigm-shifting discoveries. Already, the conversation around 3I Atlas has been charged with tension. NASA has publicly dismissed suggestions that it could be alien in origin, insisting that the available evidence aligns with standard cometary physics. Yet critics warn that institutional caution, while necessary to guard against false claims, risks turning into a reflexive denial of possibilities that fall outside the familiar. The vehemence with which unconventional ideas are sometimes attacked suggests a deeper anxiety that humanity may not be ready to face what such a discovery would mean. The object itself remains indifferent to our speculations. Silent and inscrutable, it continues along its path, a messenger from the deep. But the laws of physics ensure that 3I Atlas cannot hide forever. As it approaches perihelion in late 2025, the sun will heat it, its ices will either sublimate or remain inert, and its light curve and spectra will reveal the truth. If it brightens dramatically and sprouts a luminous tail, NASA's classification will be vindicated, and 3I Atlas will take its place as the most spectacular comet of interstellar origin. If, however, it continues to defy natural explanations, showing unexpected behavior, unusual chemistry, or anomalous motion, then the debate will intensify, lending new weight to the boldest suspicions. Either way, the mystery will reach its climax soon, and the answers will be written in the data for all to see.
By its very arrival, 3I Atlas has already unsettled our assumptions about science, about our preparedness, and about our place in the cosmos. Whether it is comet or craft, boulder or beacon, its presence forces us to confront questions we can no longer defer. The discovery of interstellar objects reminds us that the solar system is not isolated but open, intersecting constantly with the broader galactic environment. They also remind us that our instruments and our interpretations remain works in progress. The fragility of our certainty has been laid bare. The stakes extend far beyond astronomy. Should 3I Atlas turn out to be a product of intelligence, the revelation would shake the foundations of human civilization, altering geopolitics, economies, religions, and philosophies overnight. If it is natural, it will still redefine what we thought possible of comets, challenge our models of planetary formation, and enrich our understanding of the Milky Way's planetary debris. Either way, it is already a transformative event. 3I Atlas moves on, uncaring, while we project upon it our fears, hopes, and dreams. Yet one thing is beyond dispute. It cannot remain a mystery forever. The sun will test it, telescopes will capture it, and the data will flow. And when that data arrives, the truth, whatever it may be, will ripple outward across the world, reshaping science, society, and perhaps civilization itself.